Hello everyone, welcome back to ptet.chemistry channel. So this is a continuation of the year 11 revision on periodic table, which include this idea of metals. The next bit, which is this tutorial, is basically talking about extraction of metals. For that, we need to revisit the metal reactivity series. So we talk about the reactivity series going from the most reactive metal to the less reactive metal. We have an easy way of remembering them. So it's like posom, so that is magnesium, aluminium. So posokama, and then it's zil, so it's zinc, and then iron, because iron, even though it's Fe symbol, but we pronounce it as iron, so it starts with I, so it's zil, Z-I-L, so that is lead. So posokama, and then zil, because zinc, iron, and lead. And then after that, we have hydrogen and copper and silver and gold. So carbon doesn't appear in there very easily. You need to be aware, as I talk about towards the end of the last tutorial video. I think I might have made a mistake in that video. Anyway, now I know carbon is actually between aluminium and zinc. So carbon is below aluminium, so we cannot get aluminium by reacting aluminium oxide with carbon, but we can get zinc from zinc oxide by reacting it with carbon. Similarly, since hydrogen is there, so we're going to be talking about it in this tutorial actually. So the next thing is X reacts. So these are four metallic elements, W, X, Y, and Z. You're reacting them with hydrochloric acid and water. These letters are not the chemical symbols of the elements, so they are just random letters. X, Y, and Z, well, X, Y, W, and Z. So first of all, this one is the only one that does not react with HCl. So it must be a metal below hydrogen in the reactivity series. So these three does not react. So does not react with dilute acid. So the fact that W does not react with HCl, W is the least reactive metal. Whereas the most reactive metal, you don't need H+, you don't need acid, they can only react with cold water. That is your very, very reactive group 1 metal, also known as alkali earth. Not alkali earth, but alkali metals. They are very reactive with water. Without needing acid, they can only react with water to give you metal hydroxide, which is alkaline in solution. So Y is going to be the most reactive metal. Now between X and Z, so X reacts with both dilute hydrochloric acid and steam. Steam is basically H2O gaseous state. That is your year 9 as well as lower secondary science. So this one does not react with steam, it reacts with acid. This can react with steam as well as acid. Acid has H+, steam doesn't have H+. So this is going to be the more reactive one because it can only react with H2O without the H+. So X is more reactive than Z, because if you compare these and also these, X can react with both of these. X is more reactive than Z, X is more reactive than Z. That's how I get the 2 marks there. Moving on to the next one. So the oxide of W is reduced by heating in a stream of hydrogen gas. So W is the least reactive metal. W does not react with acid, so W is below hydrogen, in the series, in the reactivity series, because it does not react with H+ at all. So if I just write below hydrogen so that the handwriting is a bit clearer. In the case or in the context of the question here, reduce here means it can react with hydrogen, it can gain hydrogen. So it means gain of hydrogen, or accepting hydrogen, so gain of hydrogen atoms essentially. In terms of reactivity, as I mentioned, because these metals are below hydrogen, they do not react with hydrogen, they do not react with acid, but you can get this metal by reacting their oxides or any of their salts by reacting it with hydrogen gas, because these metals are below hydrogen in the reactivity series, and therefore we can do reduction with hydrogen. So W is below hydrogen in the reactivity series, reactivity series, the metal reactivity series. Even though hydrogen is a non-metal, we know roughly where hydrogen is. All these metals below hydrogen does not react with acid, but you can get the metal from the oxide by reacting with hydrogen gas. That's reduction. So W is below hydrogen, W is less reactive because it is below hydrogen. It is less reactive than hydrogen because they want in terms of reactivity. Now state one physical properties. All metals, not just group 1 metals, but all metals, physical property. So what I can say is conducts electricity. Every single metal, can conduct electricity because, well, they're all metals. All right. Moving on to the next question. So we have copper is extracted from copper oxide by heating it with carbon. I need to go back to my reactivity series above, but what I'll do is I'll just copy this because I don't want to have to redo it from scratch. But remember what I said earlier about where carbon was. So this question is about reduction of the metal oxide by heating it with carbon. So since carbon is there, anything above carbon cannot be obtained from the oxide by reduction with carbon, by heating with carbon. But anything below carbon, you can get the metal from the oxide by heating with carbon. Copper is below carbon. Carbon is more reactive than copper. Copper is less reactive than carbon. So you can get copper from copper oxide by heating it with carbon. So what I'll get is copper oxide plus carbon. Read the question. Carbon dioxide is produced. Produce means form. So you get carbon dioxide on the right hand side because that's the product. But what else do you get? You get copper is extracted. So you get copper out as the product as well. So they're just one word equation. So I don't need any balance equation whatsoever. So essentially, the carbon steals away the oxygen and therefore form carbon dioxide, and the copper oxide loses the oxygen to the carbon, and you just get the copper metal. Moving on to the next question. So we gotta use words from the list, and this is just filling in the blank. So copper oxide is a something containing oppositely charged ions. So what we know is we have Cu2 plus and O2 minus. So let us just work very briefly on how to get to the compound formula, Cu2 plus O2 minus. Bring down the charges, and then we gotta cross multiply. When we cross multiply, we do not cross multiply the charges or the ions. We cross multiply the value. The value of this minus 2 is 2. So I just bring down the value. The value of this plus 2 is 2. I just bring down the value. But that is not the simplest ratio because you want to get the simplest whole number ratio. So you can divide by 2 both sides, and they'll give you 1 and 1. That means 1 Cu2 plus, 1 O2 minus. That gives you CuO. So it's an ionic compound containing oppositely charged ions, positive ion and negative ions. I've used ions here. So it is an ionic compound. So I want to say ionic compound, but really they say it's a. So A-E-I-O-U is a vowel, so you will have N here. So instead of ionic, I think what I'll do is I'll just write compound, but it is definitely an ionic compound because it contains 2 or more elements, one of which is metal and the other one is non-metal. How I know it cannot be ionic is because this is not an N, it's a rather than AN, which is for A-E-I-O-U. If I start with I will have an N there. In carbon dioxide as part of your biology respiration topic, you kick out or you breathe out carbon dioxide, 1 carbon and 2 oxygen. In the outer shell, carbon has 4 valence electrons, oxygen has 6 valence electrons, and after you use 2 for sharing, you still have 4 more of these dots in the outer shell. We're talking about outer shell because oxygen is in group 6. It has got 6 valence electrons, and carbon is in group 4. It's got 4 valence electrons. We are not using the total 6 electrons because carbon is essentially 2, 4. but we just look at the valence electron, which is the outermost shell electrons for forming covalent bond. We are not looking at the whole thing. Be very careful about that. I've made a mistake here, so that's not correct because I still need my 2 dot to give me my double covalent bond there and a double covalent bond there. This is called carbon dioxide. Carbon form 4 covalent bonds, oxygen form 2 covalent bonds, like that. So each molecule in one molecule of carbon dioxide, you have three something joined by covalent bonds. So this has to be covalent bond. You have 3 atoms. You do not have ions because this is what you call a simple covalent molecule. Because of the simple structure, you have low boiling point because you're just breaking weak intermolecular forces, something which is not asked here, but that is part of year 9 structure and bonding to explain the low boiling point of simple covalent molecule. In the next topic, so we're going from copper oxide to copper. So copper oxide loses oxygen, and then the oxygen is being stolen away by the carbon. So the carbon steals away the oxygen, so the carbon gains the oxygen, and the copper oxide loses the oxygen to the carbon. So copper oxide loses the oxygen. Loss of oxygen is reduction. So they're asking for, is it oxidation or is it reduction? That is your first part, and explain your answer. So what happened to copper oxide? If you look at the equation you have from the previous page, we can see that the copper oxide loses oxygen to form copper, because copper is an element, it has no more oxygen. No more oxygen, you loses oxygen to form copper. So this is reduction, because reduction is gain of hydrogen or loss of oxygen in this case. Question 19, so we have high temperatures, potassium can react with carbon dioxide. Carbon dioxide is CO2. Potassium is a group 1 element in period 4. You produce a white solid and a black solid W. So what's going to happen is you have potassium. If I just write a word equation, because we can think about potassium is a more reactive metal than carbon, I should really go back to my not my periodic table, but my metal reactivity series, which I have copied 2 times, but I'm just going to copy it below again. Actually, without copying it, maybe I should work through it again and show you how it's done. From the most reactive metal, you gotta remember the acronym so it's carmazil, so carmazil. So the Ma there actually is calcium, magnesium, aluminium. So this is Ma and then Zil. So this is your zinc, this is your iron. Iron symbol is Fe, not I, but that's how we pronounce it. Pb, and then hydrogen, copper, silver, and then you have gold. So this is the dividing line for acid. So carmazil, and we gotta know where carbon is. Carbon is in between there, so carbon is there. So potassium can react with carbon dioxide. Potassium is a more reactive metal than carbon. So potassium plus carbon dioxide, you're gonna get a white solid. Presumably the oxygen there, CO2 contain oxygen. Then you're gonna steal away the oxygen by the potassium. So potassium will gain oxygen. When potassium gain oxygen, metal and non-metal ionic compound, so metal oxide there, and you will get carbon, because the carbon dioxide loses the oxygen and now it just become carbon, and carbon is a black solid, as you know, so there's just carbon there. And they want the name of the white solid, so this is going to be your white solid after the potassium steals away the oxygen from the carbon dioxide. So this one loses oxygen, this one gains the oxygen. So the white solid is going to be potassium dioxide or potassium oxide. You don't call it potassium dioxide because it's an ionic compound. So during the reaction, the potassium gains oxygen gaining oxygen or accepts oxygen, receive oxygen. There's a word for it. It's called reduction. So it is reduced. Oh, hang on. No. I don't know what I was talking about. Gain of oxygen is oxidation. Sorry. Gain of oxygen is oxidation. So the potassium is oxidized and the carbon dioxide loses the oxygen. So the carbon dioxide is reduced. So that's the proper term for it. Reduced there. CED. Now, when the products of the reaction, so both of these products, potassium oxide and carbon, added to water, the white solid V, there's your white solid there, it dissolves, but the black solid does not dissolve. So what can you separate the carbon and the stuff that dissolve? This is a solution. Solution meaning soluble. So the white solid is soluble, V was soluble, but the black solid is carbon, so that is insoluble because it is a solid. How are you going to separate solid from solution? You're going to name the process. The process is called filtration. You can filter off insoluble stuff from soluble solution. A solution of white solid V turn universal indicator purple. So that is your K2O because it's potassium plus. This is a group 1 metal, loses 1 outer shell electrons, give you a +1. You have O2 minus. +1 and -2. When you do your cross multiply, you bring down the value of the charge, there's 1. You bring down the value of the charge, which is 2. So what this means is K plus and K plus, and what this means is O2 minus. So what you have is K plus 2 of them and O2 minus 1 of them. That's just K2O. What happened in K2O is this is a basic oxide. So what you will get in solution, you will get an alkaline or basic solution. So you get an alkaline or basic solution where the pH is greater than 7. You will get K plus and OH minus. This is called potassium hydroxide. Hydroxide ion is OH minus. So the name potassium hydroxide contain K plus and OH minus. The pH of the solution somewhere around pH 13 or pH 14. Just choose either one, would have been alright. Describe the change to the pH when you add hydrochloric acid to it. Hydrochloric acid is acidic, so pH lesser than 7. You add acid with base, what you will get is acid plus alkaline will go to salt plus water. This reaction has a name, it's called neutralization. So in a neutralization reaction, your acid become less acidic, your alkali become less alkaline, so the pH will go down to 7. They say change to the pH of the solution. They don't say change the color, they say change the pH. So pH will decrease because originally you started from pH 13 or pH 14. Now you go to pH 7, it will decrease to pH 7. Moving on to this last question in this tutorial. So we have burning sodium. Sodium burns into this gas jar containing carbon dioxide. So for the same reactivity series trend, which I had done previously. So just like in the previous question, potassium can react with carbon dioxide and the carbon dioxide loses the oxygen to the potassium. We have the same thing here. We have sodium plus carbon dioxide. So I might not have time to go through this in class. You should probably be able to see the sodium can steal away the oxygen and therefore you will get sodium oxide. We don't call it sodium dioxide because this is covalent molecule. This is an ionic compound between metal and non-metal. The carbon dioxide loses the oxygen. So what happened there is I can say that loses oxygen, that gains oxygen. So what happened there is oxidation and loss of oxygen is reduction. There's the definition of oxidation and reduction in your syllabus. So suggest the identity of the white solid. The white solid is going to be this thing here, whereas carbon is a black solid. Okay, so suggest the identity. They don't say name, they don't say formula. If you really are very good with formula, you can write down the formula of sodium oxide. If you're not very good with formula, you could have written down the name and you would have gotten away with it because they don't specify. So what type of reaction does the sodium? They are looking for the sodium. Sodium goes from sodium to sodium oxide. It gains oxygen. So when the sodium gains oxygen, we say there's oxidation there. So what type of reaction? So that is your oxidation reaction, because the sodium gains oxygen. The sodium gains oxygen. The sodium steals away the oxygen from the carbon dioxide. Now, when you add water to the products, the exact same thing as the previous question. The white solid was sodium oxide. Sodium oxide is a metal oxide, is what you call a basic oxide, because it dissolves in water to give you metal hydroxide. Metal hydroxide contains OH minus, and therefore there is your pH greater than 7. So what type of bonding is present in the white solid? The white solid was sodium oxide. What we have is Na plus, being a group 1 metal. So Na is 281. When you go to Na, it's become 28 because it loses 1 electrons. Oxygen is 26. So what happened then is it will gain 2 electrons, and you will become anion O2 minus, which become 28. Now what happened is plus 1 for the charge of Na plus, minus 2 for the O2 minus. You're going to cross multiply the value of the charges, which is 2 there, the value of the charges, which is 1 there. What that means is I don't cross multiply the ion, or the charges. I cross multiply the value. 2 here refers to 2 Na plus, so I need 2 Na plus, and I need 1 O2 minus, and therefore I can see the formula is 2 of the Na plus, 1 of the O2 minus. I have Na2O. Anyway, that's not the question they're asking. This is between metal and non-metal. That's why you get cation and anion. That's why the type of bonding, very, very straightforward to the point, without them asking you this. It's just what is the name of the bond? It's ionic bond. Now what can we do to separate black solid? The solid is insoluble, whereas you have solution, which is soluble, because this thing can dissolve in water to give you metal hydroxide, which, in solution, pH is greater than 7, is alkaline. Just like the previous bit of the question, this is called filtration. So we can filter off solid, which is insoluble, from the solution. Alright, so I think that's it for this lecture tutorial. I'll continue more questions in the next tutorials on another subsection. If that has been useful, click the button on the bottom right to subscribe to the channel, and follow me at ptet.chemistry on not on YouTube, but on Facebook, Instagram, and Twitter. That's ptet.chemistry, Facebook, Twitter, and Instagram. Alright, so thank you for watching again, and rest out any issues you have with me. If you see me in school, pass me a USB pen drive if you want the video on a USB drive offline.